Right, good afternoon, everyone. Thanks for taking the time to join us for our first session in this mini-series called YRP Bitesize. And hopefully you can see myself and my slides up on the computer. So the first session is on resignaling, if you can see that. So for those of you who don't know about the YRP, we're a not-for-profit organization run entirely by volunteers. And our key motto that we abide by is promote the rail industry as a great place to work, inspire new generation of people through STEM activities and other things, as well as develop ourselves who are already in the industry, such as sessions through these. So who am I? I'm Elliot Jordan. I'm a signalling designer at Siemens in York. So basically I started my career on the railway with a year in industry placement, which was then Invensis Rail, which became Siemens. So after I did a year in industry from Invensis, did my final year of university, came back through to Siemens on the graduate scheme for 2 years, and now I've been working in York for 4 years as a signal design engineer. I'm also part of the YRP Northeast Committee as this year's vice chair, and also I'm a part of the IRC Younger Members section. And if anybody who's doesn't know, the IRC is kind of the go-to professional body for signalling engineers. You don't have to necessarily go to it, but it is one of the go-to ones. And if you're looking at potentially getting accreditation, whether it's EngTech, Incorporated, or Chartership, it's a great way to go about doing it. So what is the YRP Bitesize? So basically it's kind of an idea of some short webinars, seminars, sort of explain to new starters, whether they're graduates, apprentices, direct new entries, about sort of what the sort of work they'll be doing in a variety of roles within the railway. So what I want to talk to you about is, say if you go into a signalling design company such as Siemens or Alstom or Amy, Volkers, Atkins, these are the sort of projects that you probably get involved in, whether you're going to be a designer, PE, installer, tester. So basically what I've got is a few scenarios of how these three different resignaling projects, so we've got Relock, Recontrol, and resignaling, and go through briefly the sort of what to expect on these sort of projects. Just before we go into them, basically the railway, for signalling at least, it uses 3 main colors. So just to help you explain the diagrams that will come up. So we use black for equipment that's going to be retained, not touched at all. Red means that there's going to be new equipment installed and tested, and green means that these pieces of equipment are going to get decommissioned and removed from the railway. So our first one is the relock. So here we're sort of more talking about changing the interlocking, basically how the railway operates safely. So what we've got here is a simple track diagram with a siding onto a main line going through the center, sidings on the left-hand side, and a junction on the right-hand side. And so our main building sort of in the center is the control center. Don't worry if you don't know what this looks like. There's a few pictures coming up at the end of the presentation to help explain these symbols a bit better. So basically, as I said, green we're getting rid of, red is a new one. So in this example, we've got a solid state interlocking, which was one of the first sort of computerized interlockings used in the UK from the 1980s onwards. And it's been replaced by a modern CBI, so a computer-based interlocking such as Westlock, a SmartLock, or maybe a Westtrace. So mainly we sort of, in these things, you can see that none of the outside equipment that the driver will see or the maintainer will see is getting altered. So in this scenario, this sort of happens when maybe the SSIs become life expired, or components aren't as readily available, or you just want to improve for future capacity, such as maybe implementing ETCS along the railway. You want to upgrade the interlocking to be able to cope with these things. But when on a sort of a project basis, there's not really much, as it's all sort of in the signalling center. It's probably one of the ones that you don't see much involvement of. Well, I've not really had much involvement, unfortunately, but it's kind of one of the smaller potential projects you could get involved with in your career. So move on to the recontrol. This sort of happens when you sort of maybe want to economize the railway a bit more, to put everything in a more of a centralized control center. So in our scenario here, we've got two, so the green buildings there, signal boxes are using an NX, so an entrance exit control panel, to signal the trains through a relay interlocking. Which these two, so you've got two of these two boxes will get closed down, and all the controls for the railway will then move into the central building, which is a newer control center that has a VDU display, so visual display unit. So this could be a WESCAD, so it's all on computer. It could be a WESCAD or a Hitachi system or a Resonate system, and this is also controlled by a computer-based interlocking. So as you see, they're still not actually making any alterations to the line side equipment. However, when it comes to design, test, and install, there may be some small alterations made within the location cases which control the outside equipment, but not a lot. Also, so on here, the diagrams, the lines that are in green and red, they're the data transmissions, or the way you're going to send the inputs and outputs from the control center to the line side equipment has changed. So if you're designing this, there'll be a lot of some alterations to the way the inputs and outputs are fed through to the outside equipment, because obviously we're removing the two NX panels into a new CBI. So you have to be able to do this in a controlled manner. So also potentially when we're doing commissionings and testing purposes, you might have to do what we call top nutting. So we do rehearsals, so we can make sure that the new interlocking, the new control center works before commissioning it into service. So one weekend you'll change over to the new interlocking, make sure the routes and the signals and the points move over correctly, and then on the same weekend put it back to the old one before you do a final sweep and change everything to the new control center. So there's a bit more. So when it comes to sort of your day job, whether it's, like I said, project engineer, design, installation, or test, you sort of have a bit more. There's a bit more involvement in it compared to the Relock, but not as much as potentially that would get involved in a resignaling project. So a final one is the resignaling. So this, I should have mentioned before that the blue line is actually just a way of sort of highlighting the boundary of the control of the signal boxes. So each signal box has a defined boundary of the equipment that it will control, that sort of thing. So the resignaling, it's kind of I guess the project you have the most involvement in, whatever you're doing. You can see there's a lot of alterations going on in this scenario here. So they got two. So the old signal control boxes, they're the actual old style lever frame with a route relay interlocking. So instead of, because you could see them sometimes, it's a lever frame, you'll have metal rods and wires controlling the signals and points, but in this instance, the points and the signals are controlled by relays, but it's more of an electromechanical interlocking. So this sort of scenario for resignaling, you might it could be done when a lot of the equipment is sort of come to its life expectancy. There may be, again, can't get parts to repair them, or they're just so degraded that in order to keep the railway running safely, they need to be all replaced with modern equivalent sort of equipment. Also, way that you might need to do resignaling is that you might have increased the line capacity, so you might want more trains or faster trains. And to do this, you need a more modern signaling system that can cope with the new trains running at higher line speeds. So, excuse me. So in this scenario, we're replacing a lot of it's actually quite, this nice used to be quite common where you're replacing old semaphore signals into new LED type signals or filament lamp signals, but this doesn't, it's coming a bit more of a rarity really as we go through into sort of upgrading, when we more resignaling is more changing old filament style lamps or LED lamps into a new control center. So this idea of taking away old lever frame boxes being a bit of a rarity at the moment. So and also during resignaling, you might want to improve. So we look at the junction onto the right of the screen. The old track diagram in the green is being removed and replaced. So there's a bit of a bottleneck here. So we're replacing that, installing new pieces of track for for more high-speed junction turnouts for the trains, getting rid of the bottleneck so we can improve train service reliability and also get faster running speeds. So if you have the faster running speeds, you can obviously put more trains on. There's also better for the customers, that sort of thing. So yeah, so I know I spoke, this has sort of been a bit of a brief overview of how the three different kind of projects works, but I know there've been a lot of symbols being shown on the on this presentation. A lot can be sort of self-explanatory. If you've been a passenger train or you've been waiting at a train station, you can sort of maybe potentially pick out what a lot of these symbols means, especially when it comes to the signals. But the control center ones are a bit, unless you sort of know what they look like, can be a bit difficult to decipher what these exactly mean. So just a bit of help you understand what these sort of symbols mean. So on the left-hand side, we've got the old lever frame box. So big mechanical levers, a lot of, depending on how far away the points of signals are, can take a lot of force to pull them over. So the dot on the little symbol at the top of the picture, that means that's the signaler. So where the signaler is in relation to the lever frame, as it were. So that black bar illustrates the levers that they will operate to change points and change the signals for the train. If anyone's interested, that's a picture I took when I was at Hebden Bridge as part of a Huddersfield Bradford resignaling project. So that's a bit of a bonus when you're out commissioning, and that you get to see a lot of these older style signal boxes and that sort of thing. So the picture in the center is our NX panel, so that means entrance exit. So the signaler will set a route by pressing a button at the start or the entrance of the route, and they'll press a button to indicate the exit of the route. And once again, the dot is a signaler, and that sort of angled parts of for the lines indicate that it's an NX panel, because they can be straight as the picture is in the center, but they can have sort of wings attached depending on the size of the control center. Again, if anyone's interested, that's the NX panel at Edge Hill signal box in Liverpool. Another commission I worked on a few years back. And then the one on the right is the more modern VDU system. So this was actually a part of the RSE Younger Members visit to the West Midlands Control Centre. So even though you've got, even on the symbol, you got the one little square box to indicate what we call a workstation. You can have multiple workstations in the signalling centre. So each signaler, they got an array of computer screens that sort of mimic diagram of the railway that they control, can have a very large sort of area that they control, and you can, within one signalling centre, you have quite a few different workstations, sort of, so you cover a very large area of the railway. So that's sort of what NetRail's wanted to do. They're wanting to sort of centralise a lot of the control of the railway to a few locations around the country. So the lever frames on the left hand side, they're sort of getting taken away from the railway quite a lot now. They're a bit of a rarity. So and NX panels, they're still going strong, quite a few of them, but once again, they're also being being replaced for more VDU style workstations for the future. Again, so here we've got some examples of signaling equipment. The picture on the left is actually when I worked on North Links for signaling. Again, a classic idea of removing semaphore signals and replacing them with more modern LED equivalents. So you notice that the signals on the left-hand side of that picture with the 3 different arms, that's basically giving the driver, they've got 3 different routes they can take for a specific route. And the ones sort of the signals on more clip, they're actually shunt signals, so for slow speed moves around a yard or sidings, that sort of thing. And then on the right, we've got 2 examples of the more modern color light signals. So the sort of center picture, we've got a 4 aspect signal with 2 route indicators. So it's more of a sort of a modern equivalent of showing the different routes that the driver can take, similar to the semaphore signals with the 3 arms on the left-hand side. And then the picture on the right is again modern equivalent 3 aspect signal with the small little signal on the left-hand side is a shunt signal, so giving slow speed routes into sidings or yards. And then the black box is actually what we call a standard indicator, so it can show an alphanumerical display to the driver. Could be a number, could be a letter, and this indicates the driver the routes that they'll take if there's some diverging routes. I mentioned about sort of route relay and the SSI. So on the left-hand side is kind of the old style route relay interlocking again. This is at Derby power signal box underneath, so the relay room that controls the Derby, immediate Derby, so well used to, it's now been replaced by more modern VDU equivalent and a CBI. So you can see this in a relay room, you could have banks and banks of relays to control movements of the trains, signal indications, the way the points need to move from left to right, and also feedback information to signalers, such as if the train is whereabouts the train is on their diagrams, what color the signals are showing, what direction the points are, and then the picture on the right is picture of an old SSI, so the solid state interlocking rack. So in there, it's actually sort of using computer programming language to do the job of the relays on the left. But again, this is sort of the solid state interlocking. It's the sort of first computerized interlocking that the UK used from the 1980s. As you can see, that one cubicle can do all the job of the relays on the left-hand side. So again, more modern equivalent is to sort of reduce space as well as improve on things such as reliability and that sort of thing. Unfortunately, I didn't have a picture of the sort of the CBI equivalent, whether it's a Westlock or a smart lock. But so the model equivalent of smart lock or the Westlock, they can actually control 3 to 4 times the area that the old SSI can. So every time you're sort of making a new generation of interlocking, you're able to control more of the railway in less space. So that is always a bonus for the way Network Rail wants to sort of centralize its interlocking and the way it controls the trains. Hopefully that was you found that quite interesting and insightful. Just going to do it. So yeah, if you have any questions, hopefully I can answer them if we got any questions. Okay, let's see. So first question got asked, what do you find most difficult in your job? What about rewarding? I think probably the difficult part is because the way I work, you're kind of a bit siloed. It's a bit hard to sometimes see the bigger picture of the railway, especially in the resignaling sort of part of it. You sort of understand that the railway is actually a system of systems. And this is something you sort of only realize once you get involved in larger projects. So essentially, yeah, interacting with other disciplines, whether it's electrification, PWA, other signalling contractors, it can be quite difficult about the job. It's that interaction with other people can be sometimes challenging, especially if you're working to tight deadlines. Definitely a bit of a hard one. But the rewarding part, I think, is that you've actually been able to you're sort of building and installing, testing equipment that's going to give people a safe journey on the railway. So it's quite rewarding that you've been able to do something like that. Even though it's quite technical, you're still able to provide that sort of level of safety for the travelling public and the freight around the country. Do we have any more questions at all? Okay. So we've got another question about how long it would take to decide whether you replace or upgrade. So it's the sort of the changes are brought upon by the RAM, so the route asset manager, who works as part of Network Rail. They'll obviously they have a large area of infrastructure they take care of, and they'll go around, do asset management. They look into things such as if like signal bases, if they're corroded or rusted, obviously that's a safety hazard to them. You don't want them to fall down in front of a train. You look at sort of how long they've been installed for, so you do visual inspection of sort of especially with wiring. You get things called wire degradation. So obviously things like the rubber around wiring can become very brittle or soft, and this can fall off and cause a bit of electrical hazard, which we don't want. So a lot of things go into the idea of whether you choose a relock, a recontrol, or a resignaling project. You sort of look at the whole thing, where things going to bring improvements or bring better life expectancy, or maybe you're thinking about in the future when you want to incorporate ETCS into the system. Those sort of things give you an idea of what sort of approach you should take to renewing the infrastructure. So hopefully that answered the question. Best part of my career, I think it's probably understanding how much signalling's come from originally and how far it's got to go. There's always something new to learn. A lot of old technology, new technology is always, especially interested in that sort of thing. There's a lot to learn, and sort of gain in your career in an engineering sort of view. There's been some really interesting projects I've worked on, looking at a lot of old legacy equipment as well as new stuff, and it always keeps me interested in the job, as it were. So another question is, what changes will digital signalling bring to your job / signalling? I think probably the biggest one is how sort of, so as Siemens, we sort of will build our projects for our customer mainly, which is Network Rail. Sometimes we do projects for London Underground. The biggest implementation issue is probably what the customer requires, what their requirement is, because they have a lot of sway in what things they want to do and put into it. Another thing is probably the actual engineers on the ground. So obviously, it's new equipment. The industries, especially signalling, you've got a lot of older people coming up to their retirement, and it's how do you train the next generation of signalling engineers of how they're going to work this equipment, because if that knowledge basis goes, you're going to be a bit stuck. So I think it's going to be how the knowledge and how you're going to implement the digital signalling is going to be probably the big one. Another question: what advice would you give to someone who wants to get into signalling? Also a bit of a tricky one, really. I mean, for me, I've always had an interest in railways, so getting into a company like Siemens has always been a bit of a dream come true. Being able to do something I really enjoy is always a great thing. But if you are interested in getting involved in the signaling engineering type of career, definitely check out the IRC website. They've got a good way of understanding what it takes to become into what sort of involvement there are in for signaling projects, that sort of thing. Depending on if you're coming out of school, university sort of thing. Obviously, there's the apprenticeship schemes. They're really good. I've worked with a lot of great people who've come through the apprenticeship schemes at Siemens. They're really great guys to work with. Really got a lot of respect for them. And also graduate schemes as well. If you're coming from the university route, they're definitely good ways of sort of getting your foot in the door for the sort of signaling careers. Think that's about it for questions. But yeah, so thanks for everyone joining today. Hopefully you've learned something. Hopefully you've been able to explain the sort of role, what you might get involved if you are going to go into the signaling sort of realm, or you're already in the signaling realm. Thanks to Lorena in the work in the background to help bring the questions across. Really appreciate that. And also we've got another YRP Bitesize session this coming Thursday with another Northeast Committee member, Vanessa Stanley. She's going to be talking about electrification digital subsystems. So hopefully see you there. Also, if you're not already a member of the YRP, go to the YRP website, sign up. It's free, and you can keep up to date with future events like this. So yeah, if you haven't already signed up, then yeah, definitely sign up for the YRP. And also, if you're interested in maybe even getting involved in the committees, just you'll be able to there's sort of committees all across the UK. So if you're interested in becoming part of any of the committees around the UK, definitely check out the YRP website and use the contact facility to get involved. So yeah, thanks everyone for joining today. Hope you learned something.